Alright, so let's talk about compound events. What I suggest you do is pause the video and read through this slide and then resume, and I'll give some commentary. Alright, so when two events are combined, the result is known as a compound event. We normally talk about combining events as saying A and B or A or B. In the table we had event A, which was someone who enjoys school, and event B is someone who travels to school by bus. A and B means that both of those are true for a person. That means that they must enjoy school and also travel to school by bus. A or B means one or the other or both events, and it's worth actually committing that phrase to memory. One or the other or both events are satisfied. And as we saw on the previous slide, and is the same as intersection, and or is the same as union. Time for another example, and here we return to the familiar dice questions. We have a red die and a blue die, which we're rolling simultaneously or together. And part A asks, what is the probability of a 4 with the red die and a 2 with the blue die? The word "and" means intersection. Now you could do this with a two-way table by filling in each of the 36 cells, but in fact a grid diagram is just a simpler way of representing that information. And you can see that there is 1 point of intersection for the red 4 and the blue 2, which means 1 chance out of 36, so a probability of 1 over 36. The key idea is that "and" for compound events means intersection. In part B, what is the probability of a 3 red or a 5 blue? So "or" means one or the other or both. So we're going to need to highlight a whole column and a whole row, and once again there's a point of intersection that we must not count twice. So there's 6 down, 6 across, which is 12, and then minus 1 gives us 11 out of 36. Part C is asking for the probability of rolling a 2 with the red die or having both die sum to equal 4. So we can highlight the row corresponding to a red 2, and if you look at all the possible combinations that add to 4, you'll find there are 3. Because this is an OR question, we need to identify that point of intersection and remember not to count it twice, so we need to subtract 1 from our total. So we have 1, 2, 3, 4, 5, 6, 7, 8 points on the grid. So the probability is 8 out of 36, or just 2 over 9. One final example that includes conditional probability. And once again, I just recommend that you read through the slide, hit the pause button on YouTube, and resume when you're ready. Alright, so it's a political voting kind of question, and we have a two-way table we need to complete, so that's easy enough to go ahead and do. Just one tip, make sure that all of the numbers in the total columns do in fact add up correctly, otherwise that means you've made a mistake. Okay, so let's take each one at a time. What's the probability that a voter is from electorate B? Well, there's 100 people in total from electorate B out of a total sample space size of 250, so the probability is 0.4. Someone who votes for party X, there are 109 people who voted for party X in total out of 250, so that's a probability of 0.436. So far so good. Someone who votes for neither party X nor party Y, there's only one other possibility, which is that they voted independent. So we're finding the probability that someone voted independent, and there were 40 in total out of 250, or 0.16. In part 4 we have our first compound example. Someone who votes for party Y and is from electorate A. This is an intersection of a row and a column. There are 60 people in electorate A who also voted for Y. So probability of Y intersection A equals 60 over 250, 0.24. Number 5 is an AND kind of compound probability. They must be from electorate B and vote for a party other than X, which means they could have voted for party Y or independent. We know they have to be from electorate B, and they're either voting for Y or independent. Now, to write that using proper notation is a little bit more complex. It's the probability of B intersection with the probability of Y or independent, or Y union independent. But the numbers work out pretty simply. It's just 41 plus 24 over 250, which is 0.26. The next one, someone who is from electorate B or votes for party Y. So B or Y, in other words B union Y, is the probability of B, using that rule again, plus the probability of Y, minus the probability of the intersection of B with Y, to make sure we don't count those numbers twice. So it's 100 over 250 plus 101 over 250 minus 41 over 250. 41 is the intersection of B and Y. And those numbers work out to give us a probability of 0.64. None of these have been conditional probability examples so far, but in part 7 we see something different. We're trying to find the probability of someone voting independent given that he or she is from electorate A. So how do we write this? It's the probability of someone voting independent given that they are from electorate A. And the sample space is now just 150. It's a subset of the original sample space of 250 individuals. We know that they're in electorate A, and if they have voted independent, there is in fact only 16 people out of 150, so the probability is 0.11. In part C, it's a worded problem that does include the idea of conditional probability. This voter is declaring, "I will never vote for party Y," so we can assume that they either voted for party X or independent. So the notation would be finding the probability of someone being in electorate B given that they voted for X or independently. So we're interested in electorate B, and the number of people who voted for party X or independent is just 35 plus 24. And the total sample space, we know that they did not vote for party Y, so the total number of people it could be is 109 plus 40. So this problem is a little bit different than what we've done before, because we need to work out the number of people in the sample space a little bit differently. We're combining two totals instead of just looking for one. So those numbers work out to be 59 over 149, which equals 0.40. That concludes our lesson on conditional probability. We've done a range of problems that include the idea. Remember the notation and the rules that we revised, and see how you go.